Welcome to Brain Vision.
So in this particular case, what we are going to do is as follows. The surface at which it hits, we are going to decompose it into tangential direction and the normal direction. So the initial momentum mv0 this angle is 60 degree, so that is 30 degree. So the normal component becomes mv0 cosine 30 degree, and the tangential component becomes mv0 sine 30 degree. Now, momentum along the tangential direction is conserved. So we will find that tangential velocity after the collision is given by v sine 30 degree and or v0 sine 30 degree. v0 is 25 feet per second. So the tangential velocity comes out to be 12.5 feet per second. Now we have to use the coefficient of restitution in the normal direction. So normal velocity after the collision becomes E times v0 cosine 30 degree, coefficient of restitution being 0.9, the normal velocity comes out to be 19.49 feet per second. Now we should decompose Vt and Vn in the horizontal and the vertical component. So we have Vx equals Vn cosine 30 degree minus Vt sine 30 degree, and so this is my x direction and this is my y direction, absolute, horizontal and vertical. Vn sine 30 degree plus Vt cosine 30 degree, and after doing the calculation, these comes out to be the horizontal velocity 10.63 feet per second, and the vertical velocity comes out to be 20.57 feet per second. Now, what happened right now is we have Vx and Vy known, and it lands somewhere over here. So the distance is d. Finally, we have y equals 0, and we start from y naught equals 3 meter. So first, the vertical motion, we have y final equals 0 equals y initial plus vy t minus half g t squared. Solving for this, we find that the time it spends in air is 1.41 second. Now the distance it travels is over here we have got x naught equals 14.9 feet. So we find that the distance is the total distance traveled is Vx plus Vx times t plus the x naught. So basically, this distance is g and this distance is x naught. So from here we can solve for d, and we can find that the length d equals, so x naught is y naught cotangent of 60 degree. Using that, we find the length of d to be 13.25 feet.